In this video, we are going to learn how to do a RAG system in ASP.NET Core. The idea is the following. I have two documents, and I wish to ask questions about these documents. But the first one is 65 pages, and the second one is about 180 pages. Of course, they are big documents. And the problem is that I can't simply pass all of this content, this is a massive document. I cannot pass all of this content to an AI to ask questions. Why is that? Well, two reasons. The first one is that when we use AI, we pay per tokens, which means that if I try to send all of the information of this PDF to a single AI, it is going to cost a lot of money. And secondly, anyway, even if we're rich and we can spend the money, AI models don't work well with a huge amount of information. Therefore, what we're going to do is that we're going to use RAG. RAG comes from Retrieval-Augmented Generation. And it basically means that we're going to take this document, we're going to take this whole document, we're going to divide it into chunks, we're going to convert those chunks into vectors, we're going to store those vectors in a vector database, and then we're going to use something called semantic search so that we're going to try to retrieve the relevant information that may answer the user's question and then pass that context to the AI so that the AI can answer the question with the provided documentation. But the provided documentation is not going to be the whole document, but a subset of the document. That is basically what we're going to do in this video. But before that, if you want to learn more about how to build RAG systems, integrate AI in .NET applications, buy my course today. There is a link with a discount in the description of this video. Now, the application is already built. What we're going to do is that we're going to test it, and then I'm going to show you the code. So let's come here. I will choose a file. For example, this IMF document. I will upload the PDF. Now, what this is going to do is that it's going to divide that PDF into chunks, and it is going to upload those chunks, converted as vectors alongside metadata into this search service from Azure. Of course, there are many providers. For this tutorial, I chose to use Azure. So as you can see, we have this screen, and here we have indexes. And these indexes, you can think of them as tables in a database, but in our case, a vector database. Now, as you can see, we have this index here, which comes from the name of this file that we have here. That is because the first thing that I do is to create the index, and then after that, I upload the vectors. Now, as you can see here, this has finished. So let me also upload the other document, Dominican Republic, which talks about my country. Alright, so upload PDF. And if we come here and we refresh, you are going to see that we have Dominican Republic because the index is the first thing that gets created. After that, we upload the vectors. Now, again, we have to wait a few seconds, so let's do that before we ask questions about the documents. Alright, this is done. Now, I can select a document like this one, for example, and let me ask a question about the document. For example, this question, ask, and this is the response. And if I come here to this document in page 14, it has that information. Alright, let's come here. And now let's pretend that I want to ask that same question, but using this document as reference, ask. And as you can see, the provided documentation does not answer the question asked. So let me ask a question that's contained in this document, like this one, ask, and it says this, which is here in this document in page 10. Here is that same information. Alright, so this is good. This is working. Now, let's see how we build this. Let's come to Visual Studio. And here, as you can see, we have these three packages. The first one allows us to easily communicate with the Azure Search service, with this service that we have here. Alright, the second package is Microsoft Extensions AI OpenAI, which allows us to use the Microsoft Extensions AI library and use it with OpenAI. Finally, we have this PDFpick library so that we can get the contents of the PDF. Alright, so let's come to the program class. We have to configure the services, we have this rack service, which we're going to see in a few minutes. We also have this iChat client, which is an abstraction of a chat client. And in this case, we're using OpenAI, of course. And also we have this chat client using this model. And then we return that client. And finally, we have this embedding generator, which, as its name implies, allows us to generate embeddings. Embeddings mean those embeddings are the vector representations of the texts. So as you can see here, we use OpenAI key, embedding generator model, embedding client, and we return that client. And this data that we have here, all of this, is here in secrets.json. We have the OpenAI key, Azure Search, the endpoint, which is the URL, which is this URL that we have here in overview, this URL, and also here in keys, we have a key, a secret key, of course, and here we have that API key. And the embedding generator model, in our case, is this model, which again comes from OpenAI. Alright, so then we have this home controller. In this home controller, we have three actions: index, upload PDF, and ask. In index, we load the indexes. Those indexes are these indexes that we have here. But let's see how we do that. Let's come here, F12. Here we say await service get existing indexes. And in here, we instantiate a search client, a search index client, passing the endpoint of Azure Search and also the API key. Then we have indexes here, and we return these indexes. And that is how we have here these indexes, which of course come from here. Now, after that, we have this second action here. After index, we have upload PDF, in which we can upload a PDF. Here we have the iForm file. Here in service, we have process PDF. And then in here, we have an index name. We basically made the index name from the file name. But since we cannot use spaces, we substitute them with dashes. And we also can't use uppercase letters. And that is why we use to lower. Also, we cannot have special characters like commas. So if you want to use this in production, make sure to remove all of that. Then we say await create index if it not exists. So F12, here we have the endpoint API key and index name. We instantiate a search index client using the endpoint and the API key from Azure. We get the indexes if the index already exists. Then we simply return. Otherwise, we create that so-called vector table that we have here. And I call it vector table because the analogy allows us to understand that those tables will also have columns, and those columns will come from this document fragment class that we have here, which is a custom class that has an ID, the content, which is the text content from the chunk, the fragment number, which will allow us to have our contents in a sequential order. That is going to be very important, but more on that later. And here we have the embedding itself. That is the vector. That is why it is an array of float. Here we have vector search field, vector search dimensions, this number, which is the configuration of this model that we have here. Of course, that implies that other models may have other dimensions. Also, we have here this vector search profile name, which allows us to put a name to the search algorithm that we're going to use. Alright, so now we can come here, and so we have the fields of that table. Also, we have this vector search. Here we have the profile, vector profile, and the algorithms. And in our case, it is this algorithm that we have here. Alright, so then we say search index, which is our quote-unquote table, and then we create that table. Alright, and then after this, so we have to come here. Alright, so we are back in process PDF. We create the index, then we instantiate the search client. Now we can pass the index name because that index already exists. So here we have a list of document fragment. Then we open the stream, and then we use get pages. And here in get pages, we use our PDF pick library to get the contents of the PDF. And here, as you can see, we say get pages, select text where the content of the page is not null or empty or white space. And then we do a toList. So in here we have a list of strings that represents the pages of the PDF. Now, in our case, these are going to be our chunks. There are many ways of configuring the chunks. In some cases, you can use paragraphs. Like for example, every 3 paragraphs is a chunk. I have also seen that some people use characters, like every 1000, 2000 characters are a chunk. There are many ways. Just to keep this tutorial simple, I choose to do pages. And in my case, it worked very well. Alright, so after get pages, so we have the pages or fragments, then we iterate each fragment and we use the embedding generator to generate a vector from those fragments. So here we have the embedding. We generate this valid name that we're going to put in the ID of the vector. So we have the valid name, the number, and a GUID. Then we have content, the content of the vector, the text content of the vector, of course, the fragment number, which in our case is the page number, and the embedding, which is the vector itself. Now after we fill this documents list, then we say if documents has any elements, then we upload those documents, which is what we have here. Document count 65 in one case and this count in the other case. Alright, and that is how we upload the embeddings of each document. Now finally, here in Home Controller, we have the third and final action, which is ask, which is what we have here when we put a question here. So we select a document and then put a question here and click on ask. That invokes this method that we have here, which receives an index name and a question. So we say here service answer question F12. So we have here index name and question. We instantiate a search client. Then we say question embedding. Of course, we need an embedding of the question because we're going to put that embedding and use it as a reference to search for other similar embeddings, for other similar vectors. So we're going to say var top 2, which means that we're going to select the 2 closest vectors. Of course, because maybe, just maybe, the closest vector does not have the answer to the question. Therefore, we choose the top 2. Alright, so then we say search options, size top, select the ID of the vector, the content, the text content, because that is what we're going to pass to the AI, and the fragment number. And we're going to see why we need a fragment number in just a second. So then we say vector search, queries, vectorized query, question embedding. We're going to get the top 2, and we're going to compare using the field embedding. Alright, so then we get a response. We use the search client and get a response. Then we say found fragments, and we use a minimum score. This means that, of course, you have a vector, that is the question, and you're going to try to get the closest vectors. But what happens if the closest vectors are still very dissimilar, very different? Then it doesn't make sense to use those vectors. So what this search gives us is not simply the closest vectors, but also a score. A score that is a number between 0 and 1. The higher the number, the better. But if those numbers are below this minimum score, then we don't want them, because they're basically irrelevant. And therefore, if item score is less than the minimum score, then we're simply going to skip that vector. Otherwise, we're going to add it to these found fragments. And if we finish this, and there are no found fragments, which means that there are no relevant vectors to use, then we're simply going to say the provided documentation does not answer the question asked. And that is what we got here. When I ask a question like this, for example, to this document, we're not going to find any relevant vectors. Therefore, we simply are going to get here the provided documentation does not answer the question asked, which is this string that we have here. Alright, so then, why do we need this fragment number from here? Why is that? Well, I want you to visualize something. Let's come here, and let's notice that here, in this page, we have this text here, right? This text starts here and ends in the following page. But remember that our chunks are per page. Therefore, this sentence here that starts here is in one chunk, and the second half of that sentence is in another chunk. Therefore, the idea is incomplete. So an AI cannot use it effectively. So what do we do in those scenarios? Simply, if for example, we get this page as a return vector, besides this page, we're going to get the previous page and the following page. And in that way, we're going to be able to provide richer context to the AI. And that is exactly what we're doing here. As you can see, we have fragment numbers, right? Here in found fragments, we say select many, and we get, for example, this was page 10, I believe. Yes, page 10. Therefore, this may be page 10, and so we're also going to get page 9 and page 11. And that is why it was so important for us to also store the fragment number, so that it is easier for us to get the context, the full context, the previous page and the next page. So that is what we do here. Here we're going to have, for example, fragment numbers 9, 10, and 11. And then here, we come here, and we're going to do the following filter. As you can see here, what we have is an OR here, because what I want to say is fragment number, give me those vectors with fragment number equal to, this equal comes from this EQ equal, and the n, which is the fragment number that we have here. So for example, we're going to have 9, or then we're going to have this fragment number equal to 10, or fragment number equal to 11. And in this way, we're going to get these 3 vectors. But instead of using semantic search, we're simply going to search them by their fragment number. And that is why here we have in fragment number is filterable, because I want to be able to filter by this field that we have here. Therefore, let's come back here and let's see that this is basically what we're going to have here in neighbors filter. And then we say neighbors options. The size is going to be the number of fragment numbers, which is this list that we have here. That is the amount of fragment numbers. The filter is going to be this neighbor filter that we have here, this filter that we have here. And select, we have here ID, content, and fragment number. And then in here we have neighbor response. We do the search one more time, but this time using this filter that we have here. So we get back a response, and then we have here text fragment, list of a string. We're going to do a for each to this response, and we're going to get all of the contents. Then we have here text fragment, distinct to list, just in case there is a repeated page. This shouldn't be happening, but just in case we put this here. And finally, we pass the question and the text fragment to the AI. So let's come here. And as you can see here, we have a system prompt. You are an assistant who answers questions using only the provided documentation. And as you can see, we have these rules here, and answer briefly and directly. Here we have the context. This context is simply this text that we have here, which is the context. So basically here we have the following. Let me say this. All right, let me say context 1, for example. This is like page 9, the contents of page 9. Then context 2, which is basically the context, for example, of page 10. And also context 3, and so on and so forth. So in this way, the AI is going to have the full context. And now with this, we can have this list of messages because we have to pass the system prompt, the context of the provided documentation, and also the question of the user. We pass that to the AI using the chat client, the iChat client, and then we get back a response, and we pass the text of the response. And that's actually it. With that code, we have this working RAG system in ASP.NET Core. Let me know in the comments what you want the next tutorial to be. Thank you.